Welcome biology students. I'm going to be going through this reading over homeostasis for those of you that would like to follow along with me as we go through this. Recall, as we go through the reading, I'm looking for you to annotate the text, which would mean I'm looking for you to locate the terms that are bolded, such as homeostasis right here, and then highlight the definitions or explanations of these as they come up in the reading itself. Also, above each paragraph, give me a title for that paragraph, similar to what you would title a book. And each paragraph, I want a different title for each paragraph. Underneath each paragraph, summarize the paragraph to me in no more than one sentence. And then lastly, as we go through the reading, please be sure to answer the questions along the way. There are one of two ways that you really can go through this. The first would be follow along with me as I read through the paragraphs, and then go back through on your own and do the annotations, or listen to me as I read, and then pause as needed to complete some of these tasks as you go through. So beginning. Our bodies go through a process known as homeostasis. Homeostasis refers to the ability of our bodies to make changes in order to keep our bodies from becoming not normal. Our bodies have normal ranges for literally everything. For example, the typical heart rate of an adult human is 72 beats per minute. How does yours compare to this? The average person takes 12 breaths per minute. The average person has a body temperature of 98.6 degrees. These are just a few examples that you probably can relate to. However, it is important to note that while these numbers discussed above are for the average typical adult, some people do have values that are above or below these, but they are still considered normal for them. An example of this for myself is my heart rate. My normal heart rate is about 56 beats per minute. Not normal compared to the average human, but normal for me. Considering that we have normal values for every bodily process, does this mean that these values are static and not changing? The answer to this is obviously no. We are aware that there are times when our heart rate increases or decreases, times when your body temperature increases or decreases, times when our breathing rate increases or decreases. What we need to consider is what causes these changes, how our body reacts when these changes are experienced, and ultimately, why our bodies make these changes. Consider and answer these questions as you've experienced all of the following changes in your life. These would be questions I would be looking for you to answer. The first one, how does your body react when your body temperature becomes too warm? In other words, what does your body do? And why does your body do this? The second question that you need to respond to, how does your body react when your temperature becomes too cold? In other words, what does your body do when it becomes too cold? And why does your body do this? The third one, what would cause your heart rate to increase? Why does your body do that? Number 4, what would cause your breathing rate to increase? Why does your body do that? Okay, the next part of the reading, going back to our annotations, is going to tie in this picture that we see right here. It will be referenced in the following paragraph. The graph above illustrates what is known as negative feedback. Negative feedback is a part of homeostasis. The purpose of negative feedback is for our bodies to detect those moments when our bodies move away from what is normal and make changes so that we go back to normal. In the graph, you will notice a dashed horizontal line. You see that right here. The dashed horizontal line, this line represents what is normal, and it is called the set point. So this dashed line, it is known as the set point. And we see that right here, and right here. Referencing some of the previous examples, the set point for a typical adult's heart rate would be 72 beats per minute. Why? Because that's normal for the average person. The set point for breathing rate would be 12 breaths per minute. Why? Because that's normal for the average person. And the set point for temperature would be 98.6 degrees. Once again, because that is normal for the average person. As we can see in the graph above here, there are moments when we can go above the set point, and there are times when our bodies can drop below the set point. So here's our set point. Let's say this is body temperature, 98.6 degrees. If we go above it, we're going above 98.6 degrees, but then our body makes changes to bring us back down to that set point. Similarly, if our body temperature goes below 98.6 degrees, some corrective action or change is made to bring us back up to a normal body temperature. Let's use body temperature as an example, which I just kind of discussed. The set point is 98.6 degrees, so that is the value of the horizontal line in the graph. When our bodies start to become too warm, such as when we are running, our bodies react by sweating. The whole purpose of sweating is to cool our bodies and return our body temperature back to the set point. Sweating would be indicated by the corrective action seen above the horizontal line. So sweating would occur right here, which would cause body temperature to decrease. Opposite of this is when our bodies become too cold. Our response to this is to shiver, and is represented by the corrective action noted below the dashed horizontal line. So that would be right here. Body temperature would get too cold, our body shivers, we increase body temperature. Shivering is fast muscle contractions that generate heat, which ultimately would cause our body temperature to increase back to the set point. So, as we have discussed, the purpose of negative feedback is for our body to detect changes away from the set point, then make adjustments so that our bodies return back to the set point. And we have a question that we need to answer. Why is it important that our bodies use negative feedback? In other words, why is it important for our body temperature to decrease if it starts to go above the set point? That concludes the reading portion of this. I am going to read through the task 2 and task 3 here. For task 2, I've given you 2 groupings of words. I want you to look at those words, think about what they are, and then explain to me the relationship between them, or why are they grouped together. They have connections. Explain that connection to me. You'll be doing the same for group 2. When you get to task 3, you're going to be answering multiple choice questions based on this graph right here. This graph, if we look at what it's showing us, is showing us the effects of insulin and glucagon on blood sugar levels. This text will explain what insulin and glucagon are. So we're looking at blood sugar level over on the side here, and how blood sugar in our blood changes over the course of time. So let's check out the introductory discussion. Glucose, which we learned about, plants make it, mitochondria uses it for energy, is a carbohydrate that our bodies use as a primary source of energy. Recall cellular respiration. Like every other function in the body, the amount of glucose present in our blood needs to stay at or near the set point, which would be right here. It needs to be near this. 2 hormones in our body help regulate blood glucose levels: the hormone glucagon and the hormone insulin. After eating foods, blood glucose levels drastically increase. Insulin is secreted into the bloodstream from the pancreas, which in turn removes glucose from the blood and stores it in the cells of our body. So we have a hormone going in, it's removing glucose, causing the amount of blood glucose to decrease. In contrast, After going extended periods of time without food, blood glucose levels drop right here. You may have experienced this before. Symptoms include becoming lightheaded and faint, possibly even passing out. When this occurs, glucagon is released into the blood from the pancreas, where it removes stored glucose from the cells of our body. This glucose then enters the bloodstream, and we would see blood glucose levels increase back to normal. So we do have 5 questions to answer based off of this. All of them can be answered by looking at that graph.